Number three, like it's an open discussion. Like we both are high schoolers, so there is nothing to teach. It's only to learn. So,
Mm.
what topics are we gonna cover today? Let's start with a problem, right?
I think we should discuss something first. Like, uh, oh, you know that congruency module and all. Like, of course, you know.
Now you can teach also. There are people who don't know
Okay.
congruence module. So, can you see my cursor?
Hmm?
Can you see my cursor?
Oh, oh, yes, yes.
Yeah. So let's start. So, like,
Okay.
what is this congruency module, Anant?
We can say like for any n greater than one. Like we have a fixed number n, and it's like,
Hmm.
for and it is greater than one.
Hmm.
And some xy, we can say for integers. Yes. Then if uh, not xy, x and y.
Oh, okay, right. Yeah, sorry. Yeah, they are integer.
Hmm. And if n is dividing x minus y,
Okay, if like n divides x minus
x
y.
minus y, then we can say that x is congruent to y modulo n.
Okay, so like, is it like when n divides x, the remainder is y?
Oh, yeah, yeah,
Okay, so
we can
the
say that
value of
like that.
y can, yeah, so the value of y can be from like 0 to n minus 1, right?
Yes, yes, yes. That is
Oh,
actually what residue of what x. Yeah. No,
okay,
no,
so
not x. Of n.
residue. What's this?
Yeah. It is a set of all remainders that n can have.
Okay, so, okay, remainders that n can have.
It is like a special name or something. Like
Yeah,
we use this name.
so
Yeah.
it's like a
In
fancy
like
name, right?
in convo. Yes, yes, yes. In convo.
Yeah.
Yeah.
So is it like it can have a remainder 0, it can have a remainder 1, it can have a remainder 2 till remainder 3, or till we take, if we take n is 10, so it can have a remainder till 9, right?
Yes, yes, yes. Because if we'll take remainder like 11, so
Yeah.
but it will if we'll divide 11 by 10, it will give remainder 1. So like it will repeat itself. So but we cannot have any number repeating itself in a set. So
Acha,
that's it.
yeah, like if we take, oh, sorry. So if we take like r is equals to 11, it's just 10 plus 1, right? So
Yeah, yeah, yeah. That's
that's
true.
actually great. So, Anant, can you tell, can we generalize like how many residue classes are there if we have number n?
How many for like any n?
Yeah.
Wait, like how many sets?
No, no, no. It's like how many residue classes can be formed, like remainder 0, 1.
Okay. Okay, we can have, of course, we can have n minus 1. That is very obvious. Because they cannot repeat themselves. Because they are smaller than n. So they have two unique.
Okay, so it's like remainders from 0, 1, 2, 3, 4, 5, 6 till n minus 1, right?
Yeah. I thought you're going to list it all like, I don't know.
Nah,
Like,
nah, bro. Uh, so my writing is legible, right?
Yeah, yeah. It's so nice.
Yeah, sorry, bro. Me noob actually. So, so you said like it's n minus one classes, right?
Yeah, you can say like that.
But if we see here, it's like 0, 1, 2, 3 till n
No,
minus
it's
1.
not. It
Yeah,
is
so it's
actually
like,
n. N.
yeah, it's
You
n
can say
minus
n.
1 plus 1. It's n classes.
Yeah, 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 yeah.
So, Anand, can you give a intuition? Like, we know, like, it's this uh, thing, what residue. But can you give intuition, like, what it
Yeah.
means?
It is actually like when we divide anything, literally
Hmm,
anything in the world, from
hmm,
n,
hmm.
like the only remainders possible is in this set. We cannot have anything other than this as a remainder when anything will be divided by n.
Oh, so if I
You can
divide
take
a
any
large,
number, anything.
okay. So if I divide
Yup,
a very
yup,
large
any
number,
number.
any number,
Yup, think of any big number.
it's like 2025, 2024, 2023 till
Of course, you have to take
zero
n as
zero
something,
zero
then you
one.
can divide.
Huh?
Like you cannot divide anything by n and find any remainder. Can you?
Hmm. Can we divide anything by n and find it? Yeah, it is actually a bit tough, for this big number, I guess.
You have
Like,
to you have to take any number as n. For example,
yeah.
like
So let us take a small example. N
10, of course.
divides, hmm,
By dividing, like to finding remainder by taking
yeah,
10 is easy.
you
Like
can,
n as 10, then you can divide anything.
acha, you're saying that. So if we take n as
Yeah.
7, that will give a little bit spice things up.
Oh
So if
yeah,
we take,
yeah, yeah. That is like not a very conventional number. So
yep,
nice.
I got it. So if we take 512, so if we do like normal
Like
division, it's,
first you should write all the like residue classes of 7.
acha, okay.
Yeah.
So,
Like then we can show that yep, it is in the set of that. Like when we'll find remainders, then it will give this. It is
oh
in the
yeah,
set.
that's actually a brilliant idea. So we can write residue classes of 7, right? So can you hear me?
Yeah, yeah.
Yeah, okay. So it can leave a remainder 0, 1, 2, 3, 4, 5, 6. If it leaves a remainder 7, that means it, like if we take
It is
A,
actually repeating.
yeah,
Repeating
yeah,
itself.
tell.
Yeah, zero. It is actually zero mod 7 and
Hmm.
like acha, if you're saying that if it is A, then what?
No. I was just saying like, how can we prove that the the maximum remainder we can get is n minus 1? Like there's has to be some intuitive or normal proof, right? Let us try doing. Would you do it?
Can we use contradiction? I think that will be good. Or induction.
Those are heavy terms. Uh,
Oh,
yeah, we can do it. You will. So you are going to prove it by induction. Okay.
yeah, yeah.
Yeah. So let's look at the classes first. So if we say that a number a when
I
divided by
think you
say
should first define what induction actually is.
no, you are going to do this part. I am not going to touch induction. I don't know those
No,
fancy terms. You are going to do this part.
no. I think contradiction will be fine. Like
Acha, okay, you do
no,
it by
no.
contradiction, okay?
And yeah, that will be a good one.
Yeah. So
I
Anant
don't.
is going to do by
I've not done it,
contradiction.
so
Yeah,
yeah.
it's like new to us. It's some basic things, but when you get the proof, it's clear in your mind.
Mm-hmm.
So let us say like a be any number. When divided by 7, it can be only written as 7 into any integer plus
Mm-hmm.
remainder, right?
Mm-hmm. Yep.
Yeah. So if it is like 7 into any integer plus 0, which is simply divisible by 7. So yeah, it just it is just like 7q, right?
Hmm.
Now if we say 7q plus 1, it is not divisible by 7, but we can see that the remainder when dividing by 7 comes 1.
Actually, you can write it directly by using Euclid division. Like we can have any number q if we're dividing it by 7, so it can be written as 7n plus r. Uh, so
So what is Euclid division? I don't know actually. Could you please Euclid division?
okay,
What's this, bro?
okay. It is actually a division method given by
Hmm.
Euclid to find GCD, greatest common divisor.
What is GCD, bro? Actually, I'm noob actually.
Like you have a
Let's
number
let's
AB, okay,
uh-huh.
okay.
Now even number, any number AB, then
Like just define it like in like normal combo, so it will have some common divisor, okay.
okay. Matlab
Let's
if
say let's say we have 12 and 18, okay.
12 and 18, yeah.
It will have some common divisors like numbers which are dividing 12, numbers which are dividing 18 also.
So 12 can be written as
For
1
example,
into 3 into 2 into 2, and 18 can be written
yeah,
as 1 into 3 into 3 into 2. Yeah. So,
yeah. So we have like uh, so many common divisors. Like 3 is dividing 12, 2 is dividing 12,
hmm, hmm,
2
hmm,
is means 4 is dividing 12, 9
hmm,
is
hmm,
dividing to 18, and 2 is
hmm.
dividing 18.
Yeah,
So
yeah. I can see here. Yeah.
actually I made a mistake on like 2 and 3, or we can say actually 6. 3 into 2 and
Huh.
3 into 2.
Yeah.
So 2 and
That's
3, 6. That are
much
like the
better.
common divisor. Okay.
6 into 2 is 12
Like
and 6 into 3 is 18. Yeah.
yeah. So like these are common. We can say that 6 2 and 6 3, not 3. But 6. I'm confusing myself. Like 2
No
3
problem. Just
and
take
6
it
and
easy.
1.
You can say let's talk in Hindi. That's actually good. हाँ आप
Actually,
बोलो
yeah, that
बोलो बोलो.
yeah. Actually, I'm comfortable in English right now. So,
अच्छा, okay, no problem. Yeah, you can say.
uh, like we have common divisors 1, 2, 3, and 6
Yeah.
for 12 and 18. Okay.
12
But
and 18 are
what G
common.
no, in 12 and 18
अच्छा,
we
yeah,
have
in
these
12
common
and 18.
divisors.
Yep.
Yeah, yeah. So what GCD is the greatest among these common divisors.
So it's 6 here, right?
Yeah, that's it.
Acha, that is GCD. Means if we talk about what number divides the specific number we are given, so the greatest among that is GCD.
Yep, that's it.
Oh, damn. So what is
Wonderful.
uh, Euclid division coming here, right? What is
Okay.
Euclid division?
Actually, it is a like division algorithm type thing. So for like if we'll say that we have an integer b and c, let's like we can have we are having a and b. Let's take b and c this time. Like we are having a and b throughout.
Let us take any integer. What do you want to name it? Yeah.
B and c. It has to be positive. Yeah.
B and C. Acha, it only works for positive. Okay. So
Mm-hmm.
so for all value of B, C belongs to natural number, right?
Yeah.
Okay.
So what happens if we'll divide b by c?
अच्छा, when if we divide
We
B
can
by
write
C.
like no, we can write like it as b equal to c into some integer q1, and it can give remainder as let's say r1.
Acha, okay, so B can be written in terms of C into some
Yep.
multiple plus any remainder.
Yeah, yeah. And
हाँ,
like we saw earlier that remainder when we'll divide, so it can't go past c. Like
yeah,
it
so it
has to
can
be
be,
less than c, but it
yeah,
can be
so,
zero. So
hmm,
uh, greater than like less greater than equal to r1, but less than equal to c1.
so we
Actually,
got it.
yeah, that is also true. But like, why writing c minus one? Like, you can just write less than c, strictly less than c. Yeah, yeah, that's good.
Okay, okay. So that's the Euclid algorithm. That's great.
Like
But
you
यार
can extend it. Like
यार
we
still
can
हमने अभी
find
तक,
GCD. Like
हाँ हाँ,
uh, like let's divide then. Oh,
अच्छा
we have
now,
taken actually B and C. So you're taking AB.
अच्छा we have taken B and C, sorry भाई.
Yeah, yeah, yeah.
Now let me term this GCD one. So if like if a number B is like C into Q1 plus R1, then the Euclid algorithm just say like Euclid algorithm is nothing but you have to divide this C by
Hmm.
R1. It's like
Yep,
C is
yep.
equals to
And like
R1.
it will go on. It will go on.
Yeah,
Like
it will,
when you can like like what you'll say. You can just do it, and like
yeah,
you'll divide then.
let us do some manual steps so everyone gets clarity, right?
Yeah,
समझ आ
yeah,
रहे.
yeah.
So here the first number we have B, we have taken like it's C times something plus a remainder. Now we divide that C with a remainder. So C is remainder into something plus another remainder. Now you can see this. You see this. Like we know that the remainder 1 can be from 0 to C, right?
Yep, yep, yep.
And the remainder 2 would
Now
be from 0 to
0
R2,
to
right?
R1.
R1. Yeah.
R1, R1. R2 will be like less than R1.
Yeah. R2 will be like less than R1. So
Hmm.
if we divide again, if we do this process again, we write R1 is R2 times something plus R3. Yeah.
Hmm.
So from here we can see like the R3 value would be smaller than R2.
Yep.
So
And like it can go on,
yeah,
and we
it
can
can
like say that.
many steps. It can go on to many steps depending on the number.
Yep, 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 yep.
So
So let's
Anant, can you
say it will
guarantee
go
like,
on till K.
yeah, okay. So can you
What?
guarantee like
What?
we will get a time when the remainder is zero?
Yeah, you can guarantee. Like actually, wait, wait.
Like if we say R2 is R3
Like you can,
times,
yes, yes, you can have like when anything number will be some like if will not have any common factor, then you can have like 2 equal to 2 into 1. So like you will have anything into 1 in the last, like when you have nothing in common, so it can give the remainder 0 like into, wait 1 second. Hmm. So wait, actually, can you wait for a minute? My like auntie of hostel. Wait, I'm coming.
till then let's prove this statement. Uh, I think this one is left. Yeah. Hope like the statement like if any number k is divided by c, then it is can leave remainder like 0, 1, 2, 3 till c minus 1. Not c. Let's prove this. Like, let's get the working of this. So let k be any number. By Euclid division, we can write it to c into q1 plus r. Now, you
Okay, I'm
see,
sorry.
yeah,
Hmm.
I'm just proving the previous theorem. Like, there are only remainders till c
Oh,
minus
wait.
1. It was left out.
We can have so many things from that Euclidean thing you like
Yeah, yeah,
said
yeah.
on.
So, yeah, just I'm proving this. Like, any
Okay,
number
okay,
can be
you
written
do.
as c into q1 plus r1. R1 can range from
Hmm.
0. If it is 0, then it is of course divisible by c. Or c
Hmm.
divides c into q1. If it is 1, then it doesn't divide, thus it is not divisible by c, but it leaves remainder 1 when divided by c. Just like 2 when divided by 9 is just 8. Oh, sorry, 2 4 is the 8, and then it leaves remainder 1. So it is right 2 into 4 plus 1. But like, if I go till c into q1 plus an rn, and rn is like c minus 1. So here c into q1 plus c minus 1. This is not divisible by c. So this is also a remainder. This can be also a remainder. But the next step we
Yep.
take, c into q1 plus rn, where rn is c. Then we can say that it is c into q1 plus c, which is just simply c q1 plus 1, which is also divisible by c. So you get that, right? It
Yep.
forms a
Yep.
cycle. 0,
Hmm.
1, 2, 3 till c minus 1. Then again, if you will take c, it will come at 0 remainder. So it never
And like
reaches till
in a
c.
set we cannot repeat anything. So in residue set, so it will be like 0 to c minus 1 only.
Yeah,
Nice.
yeah, yeah.
Nice.
So
Let's go
we
back to
can,
that Euclidean thing.
yeah, yeah.
So,
So Anant, have you figured out like why this thing uh leaves remainder 0 at last?
yeah, I think I told you. Like when even if it'll not uh, like the quotient will be like something uh, not very what conventional for that uh, what is dividend uh,
Mm-hmm.
still like if we'll proceed then at some point we can get the quotient as q like not q it is we can get quotient as 1 so if we'll get it as 1 so like of course the remainder has to become 1 because because q equal to if we can write anything like if we have rn okay so
Mm-hmm.
if we'll write rn into 1 so like rn will of course divide rn
Yeah,
so it will give
yeah,
remainder as 0
yeah,
like any number will divide any number will divide itself so we can say that 1 is the quotient in that case so it will give as the remainder as 0 so that's the thing
yeah, yeah, we can say that.
yeah
So
hmm.
now we just have proved. Okay, wait, let me zoom it. Acha, can we say that like, can we say one more thing? Yeah, your point was solid. But can we add one more thing, this thing, like, as we can see, the remainder is shortening. Like R3 was greater than R4,
Hmm,
then
hmm, hmm,
R4 was greater than
hmm, hmm.
R5. So the
Yep, yep.
value of remainder is decreasing step by step, step by step, step by step.
Yeah.
So there is a time where the remainder would be 0, right?
Hmm.
And if it is 0, then yeah, the number is dividing itself, the thing that you said.
And we can say that like let's
Hmm.
write another term where like remainder is actually 0. Like you can
Let me do that.
remove that R term.
Let
Yeah.
let us do a fresh thing. Okay. Let us took 6 and divided by 120. Okay.
Okay, don't take numbers right now. Like, let's
Okay.
just make this Rn plus 1 Qn and remove the remainder because we have remainder as 0.
Okay, let's
Like,
start from
let's write
scratch.
the right
Let's start.
last case.
Acha,
Okay,
okay. So
okay.
it's like Rn is equals to Rn plus 1 into Qn plus 2 plus Rn plus 2. This one.
Yeah, yeah. Let's like make it 0. Remainder.
Acha, yeah. So if this is 0, then yeah,
I think you
Rn.
should go back to where you did that Euclidean algorithm thing.
Okay.
It will be more
No.
clear then.
So let me erase this first. Nice.
Yeah, yeah. Now write the term like that you were writing.
It is
Just
written here.
down here.
This one.
No, actually, I'm saying that let's like okay, whatever you want. But you can write that remove that r term rn plus 2 term to make it as 0
Okay. So Rn.
because we have just like I think we have proved like in just convo that we can have r as 0
Yeah, yeah.
and we
मतलब
cannot have
it is a
anything
degenerating sequence.
further.
So yeah, कभी तो वो zero होना ही होना है.
Yes, and we can have like it will be 0 when that rn will divide this rn plus 1.
Yeah, yeah. This
Actually, not
thing.
rn plus 1 will divide rn. That's the thing. Is a divisor. Okay.
नहीं ये समझ में नहीं आया मतलब.
Rn is equal to some number into Rn plus 1.
हाँ, so Rn plus 1 divides Rn. Yeah, because Rn is the bigger number.
That, yeah, yeah, yeah. Sorry. I'm sorry.
अरे यार ठीक है, मैं थोड़ा बेवकूफ हूँ ना, तो कुछ समझ में नहीं आया मुझे. फिर.
So, like, it is if Rn plus 1 is dividing Rn,
Yeah, Rn plus 1 divides Rn.
is it? Wait, or have I made a mistake?
अरे चिल करो यार, डिस्कशन है. देखो
Actually,
अगर Rn plus 1 Rn को डिवाइड करेगा तो Rn plus 1.
yeah, yeah, that's right, that's right, that's right.
बोलो.
Actually, that's right. Like, that's correct. I thought Rn. I was confused. So we can write what's the like preceding sequence.
It's
We had
Rn minus 1 is equals to Rn into Qn plus 1 plus Rn plus 1.
okay. If
हम्म.
Rn plus 1 is dividing Rn, okay. So like and Rn minus 1 is dividing Rn.
नहीं 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 नहीं, हम यहाँ पे रिमाइंडर भी है ना, तो हम यहाँ पे कुछ कह नहीं सकते हैं कि वो डिवाइड कर रहा है या नहीं
Okay,
कर
nice.
रहा.
Oh yeah,
हम्म.
yeah, yeah. You cannot like that.
बट हम ये कह सकते हैं कि लाइक Rn plus 1 if divides Rn, then Rn plus 1 would divide Rn into Qn plus 1.
Yep, yep, yep.
हम्म. अच्छा, and Rn plus 1 divides Rn minus 1 minus Rn plus 1.
Hmm. Okay.
And since we know that Rn plus 1 divides Rn plus 1,
Oh
therefore Rn plus 1
sorry.
divides
Wait.
Rn minus 1 also.
I think you should like repeat what you actually did here.
अच्छा, let us
Like
repeat
you can
repeat
say
this thing, okay? Yeah, let us
yep,
repeat.
yep.
So we have a sequence, ठीक है, that we have seen in above like the pages. So I'm writing the last two steps. It is Rn minus 1 is equals to Rn. Okay. Rn into Q n plus 1 plus Rn plus 1. ठीक है.
Yep.
Then the next last step where we assume that the remainder came 0 is this step, right?
Yep.
Now, if the remainder is 0 and this is the big number, so we can say that Rn
Hmm.
plus 1 divides Rn. There is no ambiguity in that, right?
Hmm.
Now, if Rn plus, oh shoot, if Rn plus 1 divides Rn, and we know Rn minus 1 is just Rn into Qn plus 1 plus Rn plus 1. Now we know that Rn plus 1 is a smaller number and Rn is the bigger number. So if Rn
Yes.
plus 1 divides Rn, then Rn plus 1 will also divides Rn into some integer which is Qn plus 1, right?
Hmm. Yes.
Now,
That's correct.
if we see this equation, this one, from here we
I
can
think
get
you should
that,
mark like what is this? You can
yeah,
say it as like equation A, equation one or something.
yeah, equation 1, let us suppose. So from here we can say that Rn into Qn plus 1 is just as
I think
Rn minus 1.
you should give a fancy name like equation star or something. That will be
अच्छा ठीक
nice.
है. Okay, 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 okay.
Nice.
Yeah. So from here we infer that this number, ये जो चीज है, ये अगर हम इसको
हाँ.
लेफ्ट हैंड साइड में ले आए तो ये इसके इक्वल हो जाएगी. Rn माइनस वन
Hmm.
माइनस Rn प्लस वन.
Yes.
अच्छा, अगर ये इसको डिवाइड करते तो ऑफ कोर्स ये उसको डिवाइड करेगा, सेम बात है. Rn प्लस वन अगर इसको डिवाइड करता है तो Rn प्लस वन will डिवाइड Rn माइनस वन माइनस Rn प्लस वन. ठीक है.
How can you say this? Can you prove this argument?
हाँ हाँ, आई कैन प्रूव दैट. इफ n
Yes.
डिवाइड्स a एंड n, अच्छा, एंड इफ a इज इक्वल्स टू b, ठीक है,
Yep.
तो ऑब्वियस नहीं कि n डिवाइड्स b भी होगा.
Yeah, yeah, that's okay.
तो जो हमें तो ये पता है ना कि Rn प्लस वन डिवाइड्स Rn इंटू क्यू एन प्लस वन. अब हमने इसको ही आइसोलेट करके अगर हम इसको एलएचएल में ले आए, राइट लेफ्ट हैंड साइड में, तो Rn
Hmm.
इंटू क्यू एन प्लस वन को हम ये लिख सकते हैं Rn माइनस वन माइनस Rn प्लस वन. और अगर ये सेम चीज है तो
Hmm.
ये डिवाइड भी सेम करेंगे, राइट?
Nice. Yes. Yes. That's actually nice.
ठीक है, ये हो गया. अब हम कह सकते हैं कि Rn प्लस वन ऑफ कोर्स Rn प्लस वन को डिवाइड करेगा, ये तो हमें पता ही है, क्योंकि
Yes.
हमेशा कोई भी इंटीजर अपने आप को तो डिवाइड करता ही है.
Yes.
तो फिर ये भी है कि वो Rn माइनस वन को भी डिवाइड करेगा.
Hmm.
तो वी कैन से दैट Rn प्लस वन ऑल्सो डिवाइड्स Rn माइनस वन. ऐसे ऐसे हम जाते रहे जाते रहे जाते रहे और हमें पता चल गया ऐसे ही इसी सीक्वेंस से कि Rn प्लस वन ऑल्सो डिवाइड्स C एंड B. ये, हेलो,
Yes. Yes. I'm here.
तो यही है ना आई गेस, मतलब मैं कहीं गलत हूँ तो तुम बताओ.
No, I think this is the approach to do it.
हाँ.
Wait. Wait. Yes. Yes.
तो आपको ये क्वेश्चन डिस्कस करें, लेट्स.
Yes. Yes. Let's discuss one problem.
अच्छा
Actually,
तो
yeah,
अनंत
we have
अनंत,
said GCD. We have said
ये,
GCD. हाँ.
हाँ अनंत तुम अब जीसीडी पढ़ा दो, लाइक जीसीडी एंड कॉन्ग्रुएंसेस पढ़ा दो, फिर हम क्वेश्चंस करते हैं.
I think we have discussed GCD.
या वी हैव डिस्कस्ड
Not
जीसीडी.
what
नाउ
GCD is.
divisibility is left, right? Like the basic rules of divisibility.
Okay. So from where we should
So
start? Like exact division. So we
yeah,
can say
yeah,
like if any
from
number.
scratch, from scratch.
Nice. So if we'll say that let's take any number.
Okay.
What number? Wait. Wait. Let's take A and J.
अच्छा ठीक है, ए एंड जे, आई एन जे लेते हैं ना, आई जे में मजा
Yeah.
आता है, चलो ठीक है ए एन जे ले लेते हैं।
No, A for Anant and we like Aniket Anant same, so J for Jaiswal. So
अरे अरे ओके सॉरी भाई।
yeah. So like if like A is dividing J, so we can
अच्छा
write like A equal to, let's write it like that. No, not like this.
दिस,
Not exactly dividing. Let it is just like we are dividing it like simple integers.
अच्छा ओके
We'll
ओके,
have any
इफ
remainder.
मतलब जे इज समथिंग ए इंटू एक्स प्लस आर वन।
Yeah, yeah.
अच्छा
So
ओके।
when this R1, like we can have R1 as uh, anything from 0 to a minus 1.
क्या अभी हमने प्रूफ किया, क्योंकि अगर ए पे वापस जाएंगे तो
Yes,
वो जीरो ही
yes,
रिमाइंडर हो जाएगा इक्विवेलेंट।
yes, yes, yes.
हाँ
So in the case of 0, like when we'll have the case of 0 and R1 will be equal to 0, that's
हाँ।
the case when A is actually exactly dividing J.
अच्छा दैट इज द केस वेयर ए एग्जैक्टली
A,
डिवाइड्स ए, ओके।
yes.
अच्छा मतलब कोई
Like
भी
of
रिमाइंडर
A
नहीं,
and
अच्छा ये
J,
तो हम बात कर ही
A
चुके हैं
and
कि
J will be in. I think we should write that A and J integers. I think you should not, because we are having everything like, well, wait, I, okay,
ए एंड जे बिलोंग्स टू इंटीजर।
okay,
मतलब वही ना कि परफेक्ट डिविजिबल तब होगा जब रिमाइंडर जीरो होगा।
yes, that's the thing. We
हम्म,
can write like in that modulo thing, we can write like J will be 0 mod A,
जे जीरो मॉडल,
because we
मतलब
had
ए
reminders
डिवाइड्स जे माइनस जीरो, ए
J,
डिवाइड्स जे।
yes, J, that's the thing, yes.
एंड
Is it fine?
बोलो।
And what, like, we have to extend it, or
नहीं कोई
should
भी
we move
प्रॉपर्टी
on to
बोलो
our
जो
problem?
लाइक डिविजिबिलिटी से हो, जो हमारे क्वेश्चंस में आगे काम आ सके।
I think, but not in this problem, I think.
या नॉट इन दिस, लाइक इफ ए
That
डिवाइड्स
much
बी
is,
एंड ए डिवाइड्स सी देन ऑफ कोर्स
like
ए
you can say
डिवाइड्स,
that
नहीं नहीं
A will
नहीं, ए
divide.
डिवाइड्स
Oh
एंड
wait,
बी
you
डिवाइड्स
made,
सी, बी डिवाइड्स सी, सॉरी सॉरी।
yes. Then A will divide C. I think
सो
this is like
कैन यू
obvious.
प्रूव इट,
Like
कैन
everyone
प्रूव
should
इट,
know this. Oh yeah, yeah, yeah.
कैसे?
Let's take like A is exactly dividing B. Okay.
हाँ तो
So
बी
let's
सम
say
ऑफ
that,
ए के।
yeah, and B
हम्म,
is dividing C. So say B is some, yeah. Let's write B, like put B in. Let's name the equations.
अच्छा तो
That this is more like improper stuff. So like you can put the value of B in equation 2 from equation A.
सी इज जस्ट ए इंटू के इंटू बी।
Yeah. And K and Z are like any integers. So
या
you can say that KZ is actually K dash,
दिस,
and that's the proof. We are done. We can write
या
like we have remainder 0, and so you can say that A
हम्म,
is divided.
तो या वी आर गोना लिस्ट आउट
I
सम
think this
प्रॉपर्टीज
is
दैट, अच्छा हाँ, you can you
the
rejoin,
more, okay. Nice.
can you rejoin?
Wait, what?